What if the secrets of the universe weren't just hidden in the equations of modern physics, but etched into the ancient myths of a civilization that vanished centuries ago? The Maya, masters of astronomy and timekeeping, left behind more than just towering pyramids and cryptic calendars. Their legends speak of unseen forces, cosmic battles, and entities so vast they shaped the very fabric of reality. Today, as scientists grapple with the enigma of dark matter, an invisible substance that makes up most of the universe's mass, we're left wondering, did the Mayans know about it first? Picture this, a civilization without telescopes, without satellites, yet mapping the stars with such precision they predicted eclipses thousands of years in advance. Their priests studied the heavens not just as observers but as storytellers, weaving tales of gods who moved through darkness like wind through trees. One of their most enduring myths describes the Black Road, a shadowy pathway in the sky we now recognize as the Milky Way's dark rift, a region obscured by interstellar dust. But here's the chilling part. Modern astrophysics suggests this same zone might be dense with dark matter. Coincidence or something far more extraordinary? This isn't just about connecting dots across time. It's about asking whether ancient wisdom-held truths we're only now uncovering with billion-dollar particle detectors. The Maya saw the cosmos as alive, pulsating with energies they couldn't see but knew existed. Sound familiar? That's exactly how modern scientists describe dark matter. An invisible presence bending galaxies, warping light, and holding the universe together. So grab your metaphorical fedora, because we're about to embark on a journey where archaeology collides with astrophysics, where temple carvings might just hold clues to one of science's greatest mysteries. By the end, you'll never look at the night sky or the Mayans the same way again. The Mayan civilization didn't just watch the stars, they danced with them. While other ancient cultures tracked basic lunar cycles or seasonal shifts, the Maya engineered celestial calendars so precise they could predict planetary alignments centuries in advance. Their observatories, like the towering caracol at Chichen Itza, weren't just buildings, they were meticulously aligned with the movements of Venus, a planet they revered as both a god and a harbinger of war. Imagine a society so attuned to the cosmos that they could calculate the synodic period of Venus. That's the time it takes for the planet to return to the same position in the sky down to a fraction of a day. Modern astronomers later confirmed their calculations were off by mere hours over a span of 500 years. But their genius didn't stop there. The Dresden Codex, one of the few surviving Mayan manuscripts, reveals intricate tables forecasting solar eclipses and the trajectories of Mars and Jupiter. They even tracked the so-called zenal passage of the sun, the days it passed directly overhead, with a precision that required an understanding of Earth's tilt long before telescopes existed. What's truly staggering is that they did all this without glass lenses or metal tools. Instead, they used shadow-casting devices and naked eye observations, turning entire temples into celestial clocks. The Pyramid of Kukulkan at Chichen Itza, for example, transforms during equinoxes into a slithering serpent of light and shadow, a feat of architectural astronomy that still draws gasps today. Yet for the Maya, astronomy wasn't cold calculation, it was sacred storytelling. They saw the Milky Way not as a random scatter of stars, but as the world tree, a cosmic axis connecting the underworld, Earth, and the heavens. The Pleiades cluster, to them, it was the rattling tail of a celestial serpent. Every celestial event, from a meteor shower to a comet's passing, was woven into their mythology as a divine message. This fusion of science and spirituality hints at something profound. They weren't just mapping the sky, they believed it pulsed with unseen energies, forces modern science is only beginning to name. And that's where things get eerie, because their descriptions of these invisible forces bear an uncanny resemblance to what we now call dark matter. today's scientists peer into the void with tools the Maya could never have imagined: particle accelerators that smash atoms at nearly the speed of light, telescopes that see in X-rays and radio waves, satellites mapping the universe's faintest whispers. Yet for all our technology, we've stumbled upon a cosmic riddle that sounds ripped from an ancient myth: dark matter. Unlike stars or planets, dark matter doesn't shine, reflect, or absorb light. It's utterly invisible, but here's the mind-bending part: it makes up roughly 85% of all matter in the universe. Think of it like the hidden scaffolding of reality, an unseen force that bends galaxies into shape, keeps them from flying apart, and warps the very fabric of space-time. How do we know it's there if we can't see it? Picture spinning a bucket of water on a rope. You'd expect the water to fly out if spun too fast, but galaxies rotate at speeds that should fling their stars into the void. They don't. Something invisible, something with immense gravity, holds them together. That's dark matter's signature. We detect it the way you might sense a ghost's presence, not by seeing it, but by observing how it moves everything around it. Now, here's where the Maya send chills down a physicist's spine. While modern science uses equations and supercomputers to grapple with dark matter, the Maya spoke of cosmic forces in terms that feel hauntingly familiar. Their myths describe the breath of the sky, an invisible energy that shaped creation, flowed through sacred caves, and guided souls along the black road of the Milky Way. They didn't have the math to quantify it, but their intuition about unseen cosmic scaffolding mirrors our own struggle to explain why the universe behaves the way it does. The starkest contrast lies in methodology. Today's researchers rely on billion-dollar experiments like the Large Hadron Collider, hunting for hypothetical particles that might explain dark matter's grip on the cosmos. The Maya, meanwhile, turned temples into celestial observatories, reading the sky as both a scientific document and a divine manuscript. Where we see cold, dark matter halos enveloping galaxies, they saw the shadowy wings of the death god Camazotz stirring the heavens. Two vastly different approaches, one mathematical, one mythological, yet both circling the same profound truth. The universe is far stranger, far more alive with mystery than our eyes can perceive. Perhaps the most humbling thought of all, after centuries of scientific progress, we might be standing where the Maya once stood, gazing at the stars, whispering about forces we can't see but know must be there, waiting for the next great revelation to pull back the veil. The Mayan cosmos wasn't a cold, empty void. It was a living, breathing tapestry of forces both seen and unseen. At the heart of their cosmology lay the idea of Kaya, a sacred energy that infused everything: stones, trees, rain, even the stars. This wasn't just poetic metaphor. To the Maya, Kaya was as real as gravity, an invisible current flowing through the universe, shaping destinies and binding the spiritual to the physical. Modern physics might call it a quantum field or dark matter's gravitational pull, but the Maya perceived it as something more intimate, a divine breath animating creation. Their universe was layered, divided into 13 heavens above and 9 underworlds below, all connected by the world tree, their version of the Milky Way. But here's what's fascinating: these realms weren't just spiritual concepts, they mapped onto observable celestial phenomena. The dark rift in the Milky Way, that stripe of cosmic dust obscuring starlight. To the Maya, it was Xibalba B, the Black Road, a literal pathway to the underworld where souls journeyed and gods battled. Modern astronomers now suspect this same region is dense with dark matter, its gravity warping the light of distant stars. The Maya couldn't measure gravitational lensing, but their myths describe the Black Road as a place where the sky bends, where invisible hands tugged at the fabric of reality. Then there's the god Huracan, whose name means one-legged, a deity of storm and chaos who dwelled in the whirlwind. Ancient texts describe him as a force without form, yet heavier than stone, whose movement stirred the heavens. Replace Huracan with dark matter halo, and the description fits eerily well. Modern science tells us these vast, invisible structures surround galaxies, their immense weight dictating how stars move. The Maya even depicted cosmic battles between gods in the Popol Vuh, their sacred text where deities clashed in realms no mortal eye could see. Sound familiar? Today's astrophysicists speak of dark matter particles colliding in the voids between galaxies, their interactions shaping the universe in ways we're only beginning to understand. Perhaps the most striking parallel lies in the Mayan obsession with balance. Their universe thrived on duality, light and dark, life and death, seen and unseen. Temples were built with precise alignments to harness celestial energies, and rituals sought to appease the invisible forces governing harvests and eclipses. In a way, they were ancient scientists conducting experiments, using myth as their theoretical framework. When priests charted Venus's path or timed ceremonies to the solstices, they weren't just worshipping, they were probing the rules of a universe they sensed was far more complex than meets the eye. This convergence of myth and modern physics raises a tantalizing question. Did the Maya intuit truths about the cosmos that science is still unraveling? Without particle detectors or telescopes, they grasped that the universe was held together by forces beyond human perception. Their stories weren't mere superstition. They were models of reality built on generations of celestial observation. Today, as physicists chase dark matter through underground labs and space telescopes, we're forced to reckon with the same humbling truth the Maya knew all too well. The universe is alive with mysteries, most of which remain hidden in the shadows. Among the most profound texts left by the Maya, the Popol Vuh stands out not just as a creation myth, but as a cosmic blueprint. This sacred book, often called the Mayan Bible, doesn't merely recount the origins of the world. It paints the universe as a dynamic interplay of visible and invisible forces. One passage describes the primordial stillness before creation, when there was only the sky and the sea, and between them the Maker's word hung like mist. Modern physicists might describe this as the quantum vacuum, a seething ocean of potential energy from which particles flicker in and out of existence. But the Popol Vuh goes further, speaking of the breath of the sky, an unseen force that stirred the void, a metaphor that eerily parallels our understanding of dark matter's gravitational influence shaping the cosmos from the shadows. The text's most striking passage comes during the story of the hero twins, who descend into the underworld to battle the lords of Xibalba. Before their final confrontation, they encounter a being described as the one who holds up the sky, a colossal entity without face or form, yet whose weight bends the branches of the world tree. Ancient scribes depict this figure as a shadowy giant, arms outstretched beneath the Milky Way. Today, astrophysicists map dark matter halos, vast, invisible structures that cradle galaxies with nearly identical descriptions. The resemblance is uncanny. Both accounts speak of an unseen mass exerting invisible pressure, holding cosmic structures together against the pull of chaos. Another verse describes the gods shaping the first mountains by pressing down the darkness until it grew dense as stone. To the Maya, this wasn't just poetic imagery. It reflected their belief that the physical world emerged from concentrated unseen energies. Modern telescopes have revealed how dark matter's gravitational scaffolding guided the formation of galaxies, pulling ordinary matter into the dense knots we now see as stars and planets. The Popol Vuh even hints at dark matter's elusive nature, referring to these foundational forces as that which the owl's eye cannot glimpse, though it feels the weight of its wings. Perhaps the most tantalizing clue lies in the text's recurring motif of the black cord, a metaphysical tether connecting all layers of existence. Priests invoked it during rituals to commune with the gods, describing it as a conduit for that which flows unseen. Contemporary simulations of the cosmic web, the filamentary structure of dark matter spanning the universe, reveal a near-identical lattice of invisible threads. The Maya, of course, lacked supercomputers, yet their myths envisioned a universe woven together by dark, thread-like forces long before science confirmed their existence. What makes these parallels so compelling isn't just their accuracy, it's the Mayas' insistence that these hidden forces were alive. Unlike modern physics, which often frames dark matter as a passive gravitational glue, the Popol Vuh animates the unseen, describing it as a sentient presence with will and agency. The Lords of Xibalba don't just represent death, they embody the chaotic, destabilizing potential of dark energy. The hero twins' victory symbolizes the delicate equilibrium between visible and invisible, between the matter we see and the shadowy bulk we're still struggling to comprehend. Reading the Popol Vuh through the lens of modern astrophysics doesn't diminish its spiritual power. If anything, it amplifies it. The Maya weren't just storytellers, they were cosmic cartographers, mapping the intangible with metaphors that now ring with scientific resonance. Their breath of the sky might yet prove to be the same invisible hand that guides our telescopes toward the next great discovery. Buried within the pages of the Dresden Codex, one of only 4 surviving Mayan books, lies a celestial secret that still stuns astronomers today. This fragile bark paper manuscript, written in the 11th or 12th century but containing knowledge centuries older, isn't just a religious text. It's a precision-crafted astronomical almanac, filled with tables so accurate they predict Venus's movements 500 years into the future with a margin of error smaller than a single day. But look closer and you'll find something even more extraordinary. Diagrams of the cosmos that seem to map not just what the Maya could see, but what they felt must be there. Take the so-called serpent pages, where undulating snakes coil through star fields, their bodies marked with cryptic glyphs. At first glance, it's mythic art until you realize these serpents align with the ecliptic, the sun's path across the sky. The Maya depicted it as a celestial reptile because to them, the heavens were alive with unseen energies. One particularly haunting illustration shows a serpent swallowing a disk long interpreted as an eclipse. But the disk isn't solid. It's speckled with dots that mirror modern illustrations of dark matter's gravitational distortion, those telltale ripples in space-time caused by invisible mass. Could this be coincidence? Perhaps, but consider how the Codex's creators plotted Venus's disappearances during its inferior conjunctions when it vanishes from view behind the sun. Their calculations accounted for something modern astronomy confirms. Venus doesn't move as predicted unless unseen forces, what we'd call dark matter's gravitational influence, are factored in. The Codex's lunar tables are even more revelatory. They track not just eclipses but subtle orbital perturbations, the moon's tiny wobbles caused by the gravitational tug of something beyond Earth's pull. Modern science attributes these to the sun's gravity and the uneven distribution of mass in the solar system, much of it tied to dark matter's hidden scaffolding. Yet the Maya, working millennia before Newton penned his laws of motion, corrected their lunar calendars for these deviations with eerie precision. How? Their answer might lie in the marginalia. Scattered among the numbers are glyphs reading Keuhul Kayok, translated as sacred fire, a term they used for energies that moved invisibly through the cosmos. Then there's the infamous page 24, a cosmic diagram showing the Milky Way not as a flat band, but as a layered structure with shadowy bands crossing at oblique angles. Contemporary astronomers recognize this as the galaxy's dark matter halo, the vast invisible cocoon that envelops the visible stars. The Maya drew it as a lattice of blackened lines labeled Okbielum, the jaguar's entrance, a metaphor for portals between realms. Here's where it gets chilling. We now know dark matter's gravity creates cosmic highways, funneling galaxies into clusters along filamentary webs. The Codex's jagged lines map almost perfectly onto these modern simulations. What makes the Dresden Codex so unsettling isn't just its accuracy, It's the way the Maya achieved it. Without telescopes, they treated the night sky as a living manuscript, reading between the lines of visible light for clues to the unseen. Their Venus tables didn't just track a planet, they chronicled the dance of visible and invisible partners, a gravitational tango we're only now decoding. When modern astrophysicists peer into the Codex's star charts, they don't see primitive mythology. They see a civilization that grasped, at least metaphorically, what our equations now confirm. The universe is built on shadows, and the Maya were listening to their whispers. The Mayan pantheon wasn't just a collection of supernatural beings. It was a meticulously organized system of cosmic forces, each deity embodying a fundamental aspect of the universe's delicate equilibrium. At its summit stood Itzamna, the sky god, often depicted as a celestial serpent or a wise old man with sunken cheeks, his fingers stretching across the heavens like tendrils of dark energy. To the Maya, he wasn't merely a symbol of the sky. He was its architect, the unseen hand that held stars in place and kept the cosmos from collapsing into chaos. Modern astronomers might describe this as the gravitational web of dark matter, the invisible framework preventing galaxies from spinning apart. Itzamna's glyph, a serpentine shape studded with stars, even resembles contemporary visualizations of dark matter filaments, those vast thread-like structures connecting galaxy clusters across the void. Equally pivotal was Ixchel, the moon goddess, whose silver light wasn't just illumination but a binding force. She governed tides, menstrual cycles, and the growth of crops, all phenomena tied to cyclical gravitational pulls. The Maya revered her as the weaver of cosmic balance, her loom's threads representing the delicate interplay between seen and unseen forces. In one haunting temple mural, she's shown cradling a rabbit, the moon's shadowy markings, while standing on a twisted rope, a metaphor for the Milky Way's dark rift. Today, we know the moon's orbit is subtly perturbed by dark matter's gravitational tugs, a nuance the Maya might have intuited when they timed their sacred ceremonies to lunar standstills, those moments when the moon appears to pause in the sky, as if caught in an unseen net. Then there's Camazotz, the bat-winged death god who dwelled in the underworld's pitch-black caves. His myths describe him as the whisperer in the dark, a being whose wings stirred winds that moved stars without touch. Modern simulations show how dark matter halos, those colossal, invisible clouds enveloping galaxies, generate gravitational wakes, subtly altering the paths of nearby celestial bodies. The Maya may not have known the physics, but their stories captured the essence, an unseen entity reshaping the cosmos from the shadows. What ties these gods together is their role as custodians of balance. The Popol recounts how the gods sacrificed themselves to stabilize the world, their blood becoming the glue of the sky, a phrase that chillingly parallels dark matter's gravitational binding energy. Even their conflicts mirrored cosmic forces. When Itzamna and the storm god Chok clashed, it wasn't just a thunderstorm. It was the collision of gravitational and electromagnetic energies, the visible and invisible vying for dominance. This duality reaches its peak in the myth of the maize god's resurrection. After being dismembered and buried, he rises when the hero twins pour water, symbolizing the Milky Way, into his grave. The glyphs describe his bones shining with black light, an oxymoron that eerily evokes dark matter's paradoxical nature, invisible yet omnipresent, intangible yet indispensable. The Maya saw his rebirth as the universe's endless cycle of destruction and renewal, driven by forces both seen and unseen. Today, as physicists debate whether dark matter interacts with itself or merely bends spacetime, the Maya's gods offer a provocative lens. Their deities weren't static symbols, they were dynamic expressions of a universe alive with hidden tensions. Where we see equations describing gravitational anomalies, they saw Itzamna's fingers pressing constellations into place. Where we map dark matter's distribution with supercomputers, they painted Ixchel spinning the cosmos on her loom. The parallels don't prove the Maya knew dark matter's scientific nature, but they reveal something equally profound, a civilization that grasped in myth what we now quantify in math, that the universe dances to rhythms far deeper than light alone can reveal. To the Maya, Xibalba wasn't just a mythical underworld, it was a shadowy parallel dimension, a hidden realm where the rules of reality bent and twisted. Described in the Popol Vuh as a place of mists and endless night, its influence seeped into the world above like an invisible gravity. Rivers flowed backward, stairs shifted underfoot, and spectral lords played deadly games with mortal visitors. At first glance, this sounds like classic underworld mythology, but zoom in, and the parallels to dark matter become impossible to ignore. Modern cosmology describes dark matter as a pervasive, unseen structure shaping the visible universe from behind the curtain, its gravitational fingers tugging at galaxies like puppet strings. Xibalba, in Mayan lore, functioned the same way, an unseen domain whose rulers, the death gods, manipulated fate, disease, and even celestial events from the shadows. The architecture of Xibalba holds the first clue. Its palaces bore names like Pushing Down Darkness and House of Cold, where the air itself was described as thick yet weightless. Replace palaces with dark matter halos, and the description mirrors modern astrophysics. Vast, diffuse clouds of invisible particles enveloping galaxies, their gravity so immense it warps space-time yet remains utterly intangible. The Maya even depicted Xibalba's entrance as a black cenote, a water-filled sinkhole reflecting no light, a striking metaphor for dark matter's gravitational wells, which trap light so completely they create the cosmic equivalent of bottomless pits. But the most chilling parallel lies in Xibalba's inhabitants. The Popol Vuh describes the death gods not as singular beings, but as twinned spirits, entities that existed in pairs yet moved as one. Contemporary physics proposes a similar duality for dark matter, weakly interacting massive particles, WIMP, and actions, two hypothetical constituents of the same invisible substance. The lords of Xibalba tested visitors with impossible trials, forcing them to navigate darkened rooms or recognize their faces in smoke. Today, scientists test for dark matter by tracking its gravitational fingerprints in particle colliders or watching stars wobble inexplicably at galaxy edges. Both are attempts to discern an unseen presence through its effects on the visible world. The hero twins' journey through Xibalba reads like a dark matter allegory. To defeat the death gods, they tricked them into sacrificing themselves, then resurrected as constellations. The myth's deeper layer, transformation through unseen forces. Modern telescopes reveal how dark matter's gravity sculpts galactic evolution, funneling gas into star-forming regions. The Maya saw this creative destruction in spiritual terms. Xibalba's chaos wasn't just an end, it was a crucible where new cosmic orders emerged. Perhaps the most provocative detail is Xibalba's Black Road, a winding path souls traveled after death. The Maya aligned this with the Milky Way's dark rift, a dust-obscured lane now suspected to brim with dark matter. They believed souls had to navigate its twists to reach renewal, a metaphor that eerily echoes how galaxies must traverse dark matter's cosmic web to merge and grow. The underworld wasn't just a cautionary tale, it was the Mayans' way of mapping the universe's hidden architecture long before science had the tools to see it. Standing at the base of El Castillo, the Great Pyramid of Chichen Itza, you're not just looking at an ancient monument, you're witnessing a celestial calculator carved in stone. Every equinox as the sun sets, a serpent of light slithers down the pyramid's northern staircase, a dazzling display of the Mayan obsession with aligning architecture to the heavens. But this wasn't just spectacle, it was science. The Maya engineered their temples with mathematical precision, turning stone into observatories capable of tracking planetary movements down to the hour. And buried in their alignments are clues suggesting they might have detected anomalies invisible to the naked eye, anomalies we now attribute to dark matter's gravitational whispers. Take the Temple of the Cross at Palenque, where the central doorway frames the Milky Way's dark rift during the winter solstice, the same region modern astronomers identify as a potential dark matter hotspot. The Maya didn't just mark this event, they encoded it into the temple's reliefs, depicting gods emerging from the rift's shadowy band. Even more telling is the Temple of Kukulkan's acoustic quirk. A clap at its base produces an echo mimicking the chirp of the sacred Quetzal bird, a phenomenon caused by sound waves bouncing off precisely angled steps. Physics now shows how dark matter's gravitational lensing bends sound waves in similar ways, warping signals across cosmic distances. Could the Maya have stumbled onto a principle they couldn't name but could architecturally harness? Then there's the observatory at Chichen Itza, known as El Caracol for its spiral staircase. Its narrow windows don't just frame Venus, they track its most elusive deviations. Modern astronomers found Venus's orbit wobbles slightly due to dark matter's gravitational pull in our solar system's outskirts. The Maya, without telescopes, built sightlines capturing these minute anomalies, compensating for them in their calendars. The building's alignment is off by less than half a degree, a margin so slim it suggests they were accounting for something unseen tugging at the planets. But the most compelling evidence lies in the Pyramid of the Magician at Uxmal. Its western staircase aligns with the setting sun only during late May and July, dates with no obvious agricultural or ceremonial significance. Yet these dates coincide with Earth passing through streams of interstellar dust, now known to correlate with dark matter filaments. The pyramid's unusual oval base, defying typical Mayan design, creates shadow patterns that match modern simulations of gravitational lensing effects, those warped patches of sky where dark matter bends light. What emerges is a startling possibility. The Maya may have used architecture as a dark matter detector. By aligning temples to celestial events with near-impossible precision, they effectively turned stone into a cosmic recording device, capturing gravitational nudges and stellar wobbles that hinted at an invisible universe. They lacked our vocabulary, but their buildings speak volumes, each alignment a silent testament to a civilization that didn't just watch the stars, but listened for the secrets hidden in the spaces between them. For the Maya, blood wasn't just a bodily fluid, it was sacred currency, the medium through which mortals communed with the unseen forces holding the cosmos together. Their bloodletting rituals, often dramatized as gruesome spectacles, were anything but random acts of devotion. These ceremonies followed precise astronomical timings, synchronized with celestial events like Venus's risings or solar zenith passages. A king or queen would pierce their tongue, earlobes, or genitals with stingray spines or obsidian blades, letting crimson droplets fall onto bark paper which was then burned. The rising smoke carried prayers to the gods, but also something far more profound. The Maya believed this act released Siechulul, the life force energy that nourished the gods and maintained cosmic equilibrium. Here's where it gets spine-tingling. Modern cosmology posits that dark energy, an invisible force accelerating the universe's expansion, makes up 68% of the cosmos, while dark matter accounts for 27%. Together, these unseen elements form the scaffolding of reality. The Maya, without telescopes or particle physics, described a startlingly similar duality. Their rituals sought to balance Ka, divine energy, and Ik, the breath of life, forces they believed flowed through everything. Bloodletting wasn't mere sacrifice, it was a metaphysical transfer, replenishing the invisible energies that kept stars in motion and crops growing. Temple murals at Yaxchilan depict rulers bleeding into bowls filled with twisted cords, symbols of the Black Roads, linking earthly and celestial realms. Today, astrophysicists map dark matter's filamentary web connecting galaxies, a cosmic network uncannily mirrored in those ancient illustrations. The parallels deepen when you examine the timing. The most intense bloodletting rites occurred during periods of celestial instability, eclipses, Mercury retrogrades, or the Milky Way's dark rift aligning with the zenith. The Maya saw these events as moments when the boundary between seen and unseen worlds thinned, requiring human intervention to steady the sky. Modern science reveals that dark matter's gravitational pull intensifies during galactic alignments, subtly altering the motion of stars. The Maya couldn't measure these perturbations, but their rituals aligned with them instinctively, as if sensing the universe's hidden tremors. Even the tools used in these ceremonies hint at an eerie prescience. Obsidian blades forged from volcanic glass were considered portals to the spirit world due to their unnatural sharpness. Contemporary researchers use similarly exotic materials, ultra-pure crystals, liquid xenon, to hunt for dark matter particles in underground labs. Both approaches share a unifying principle. To detect the invisible, you must bridge the mundane and the extraordinary. Perhaps the most haunting connection lies in the Maya's concept of Itza, a viscous, luminous substance they believed coated the gods' bodies and dripped from ritual bloodletters. Described as dark yet radiant, Itza flowed through sacred trees, cave waters, and even the blood of kings. Compare this to modern descriptions of dark energy as a repulsive fluid permeating space, or dark matter's gravitational glow warping distant starlight. The Maya didn't just imagine these forces, they enacted their replenishment, one drop of blood at a time, in a ritual dance with the universe's hidden architecture. In the end, these ceremonies reveal a civilization grappling with the same existential awe that drives today's physicists. Where we deploy equations and particle colliders, the Maya wielded spines and smoke, but both pursuits share a common thread: the unshakable conviction that what we see is only a fraction of what's truly there. The long count calendar wasn't just a way for the Maya to track time. It was a cosmic heartbeat, pulsing with rhythms that stretched far beyond human lifespans. Unlike our modern Gregorian calendar, which resets every year, the long count unfolded over epochs, with each cycle building toward a grand celestial realignment. The most famous of these cycles, the 13 Bacton period spanning roughly 5,125 years, culminated in the much misunderstood end date of December 21, 2012. But the real intrigue lies not in Hollywood doomsday scenarios, but in what the Maya believed happened between these cycles, periods of cosmic recalibration where unseen forces reshaped the universe. At the core of the long count's design is the concept of world ages, each destroyed and reborn under different elemental influences. The previous age, they claimed, ended in a great flood sent by the gods to cleanse imbalance. The current one, the fourth world, was said to be governed by the sacred energy of Kaya, the same invisible force modern science might liken to dark matter's gravitational binding. The Maya didn't just see these ages as mythological eras, they calculated them with mathematical precision, tying them to the precession of the equinoxes, that 26,000-year wobble in Earth's axis. What's staggering is that precession isn't just an earthly phenomenon. It's influenced by the Milky Way's gravitational tug, a pull now attributed in part to dark matter's distribution in our galaxy's halo. The long count, then, might have been tracking subtle shifts in the unseen scaffolding of the cosmos long before physicists had the tools to measure it. Even more compelling are the calendar's shadow periods, intervals where time was considered unstable. These weren't arbitrary, they aligned with Venus's 8-year synodic cycle and the Moon's 18.6-year nodal cycle, events modern astronomy knows are affected by dark matter's gravitational perturbations. The Dresden Codex includes correction tables for these anomalies, adjusting calculations by fractions of a day to account for what the Maya called the sky's hidden breath. Today, we describe those deviations as tidal forces from dark matter's uneven distribution. Perhaps the most tantalizing clue lies in the calendar's glyph for the completion of a cycle, a turtle shell cracking open to reveal stars. In Mayan cosmology, the turtle symbolized the Earth floating in the cosmic sea, its shell representing the dome of the sky. But recent astrophysical models suggest something eerily similar, that dark matter's gravitational waves might create microscopic cracks in spacetime during galactic collisions, releasing bursts of energy. The Maya couldn't have known about gravitational waves, but their imagery suggests an intuitive grasp of cosmic forces rearranging the universe at cyclical intervals. The true genius of the long count lies in its refusal to separate time from space. Each cycle wasn't just a measure of years, it was a map of the galaxy's invisible architecture, a way to anticipate when dark matter's currents might stir the heavens. When modern scientists peer into deep-field telescope images, tracing the filamentary web of dark matter connecting galaxy clusters, they're glimpsing the same cosmic patterns the Maya encoded in stone millennia ago. The calendar's end dates weren't about doom, they were about transformation, a reminder that the universe is forever rewriting itself, guided by forces we're only beginning to name. In the shadowed jungles of the Mayan world, no creature commanded more awe than the jaguar, the elusive night sun, whose spotted coat mirrored the star-streaked sky. To the Maya, this wasn't just a powerful predator, it was a living symbol of the unseen forces weaving through creation. Jaguars were believed to move effortlessly between realms, their golden eyes piercing the veil between the physical world and the spirit dimensions. Modern science might describe this duality differently. Dark matter, though invisible, permeates every corner of the cosmos, its gravitational pull subtly guiding the motion of galaxies, much like the jaguar's silent steps shape the forest's balance. The jaguar's mythology deepens the parallel, often depicted in art with celestial markings or emerging from cave mouths portals to the underworld. It embodied the Mayan understanding of hidden energies. One striking mural at Bonampak shows a jaguar crowned with a headdress of swirling dark clouds, a visual echo of how dark matter halos encircle galaxies like ghostly crowns. Even the animal's hunting habits mirrored dark matter's behavior. Just as a jaguar's presence is often revealed only by the stirred leaves or the startled calls of birds, dark matter betrays itself not through light, but through its gravitational effects on visible matter. Other animal spirits carried similar cosmic weight. The owl, known as Mon, was considered a messenger between worlds, its ability to navigate darkness linking it to the unseen currents of Kaya. Temple carvings show owls clutching serpents in their talons, a metaphor for controlling chaotic forces, much like dark matter's gravitational scaffolding tames the random motions of stars. Then there's the bat, revered as Camazotz, whose echolocation symbolized perception beyond sight. The Maya believed bats could hear the shape of darkness, a concept uncomfortably close to how modern astronomers map dark matter by listening to gravitational waves rippling through spacetime. Perhaps the most provocative animal symbol was the cosmic turtle. Its shell, etched with constellations, represented the Milky Way's curvature, while its body floated in the primordial sea, an allegory for dark matter's invisible ocean suspending visible galaxies. The Popol describes the turtle diving to the underworld and resurfacing with new stars in its mouth, a poetic rendering of how dark matter's gravitational wells pull matter together to birth new celestial structures. What makes these animal metaphors so compelling is their layered wisdom. The Maya didn't just project human traits onto beasts, they recognized these creatures as embodiments of universal principles. A jaguar's spots weren't merely camouflage, they were a map of the cosmos's hidden patterns. An owl's flight wasn't just silent, it was a lesson in navigating the intangible. In a world without microscopes or spectrometers, the Maya turned to nature's own symbols to articulate truths we're only now verifying with supercomputers. Their animal spirits weren't superstition. They were an ancient language for describing the ineffable, a language that still whispers secrets to those willing to listen. Deep in the jungles of Mesoamerica, Mayan astrologers didn't just read the stars, they listened to the silence between them. Their zodiac, far more intricate than the 12-sign system familiar to most, was a celestial tapestry woven with constellations, planets, and something modern astronomy is only now beginning to quantify: the gravitational whispers of the unseen. Take the Mayan cosmic crocodile, a sprawling constellation stretching across the Milky Way's dark rift, its body formed not by stars but by the absence of them. To the Maya, this creature wasn't just an empty patch of sky. It was a devourer of light, a manifestation of the invisible forces shaping destiny. Today, astrophysicists map that same region as a dense knot of dark matter, its gravity bending starlight like the crocodile's jaws clamping down on celestial rivers. Their astrological system revolved around 13 constellations, each tied to a specific energy influencing human affairs. But here's what sets it apart: they didn't just track the stars' positions, they accounted for their movements through hidden realms. The constellation Ok, the turtle, associated with wisdom and longevity, was said to swim through black waters, a metaphor eerily reminiscent of how stars orbit within dark matter halos, those vast, invisible pools of mass that dictate galactic motion. Even more striking is the Lammat sign, symbolized by Venus as both morning and evening star. Mayan texts describe its shifts as guided by the breath behind the wind, an unseen push and pull modern science attributes to dark matter's gravitational nudges on planetary orbits. Perhaps the most haunting parallel lies in the Mayan concept of Wayob, personal spirit guides often depicted as animal companions. These weren't arbitrary, they were assigned based on birth dates aligned with specific celestial configurations. A child born under Chuwan, the monkey, might inherit cleverness, while Kib, the owl, conferred intuition. But the key detail: these traits were believed channeled through Ikkel, a shadowy counterpart to the visible stars. Modern astrophysics reveals that dark matter's gravitational lensing subtly distorts the light of zodiacal constellations, meaning the Maya, in a way, were accounting for dark matter's influence on astral energies millennia before we had the math to prove it. Their astrologers also tracked empty zodiac houses, sectors of the sky devoid of bright stars but rich in mythological significance. One such zone, Zibalba-Ek, the Black Road Star, was considered a portal where destinies were rewritten. Contemporary sky surveys show this region overlaps with a dark matter filament, one of the universe's massive gravity highways. The Maya interpreted its influence as chaotic yet creative, a force that could unravel plans or birth new opportunities, mirroring how dark matter's gravitational tides shear apart gas clouds only to compress them into new stars. This wasn't superstition, it was sophisticated cosmology in symbolic dress. Where Western astrology focuses on planetary alignments, the Maya layered their readings with the unseen, the gaps, the voids, the spaces between light. Their astrologers didn't just chart what glittered, they mapped the shadows that moved them long before science confirmed those shadows had mass, gravity, and a hidden hand in everything. Every year, as the sun crosses the celestial equator, something extraordinary unfolds at Chichen Itza's pyramid of Kukulkan. The setting sun casts a series of triangular shadows along the northern staircase, creating the illusion of a feathered serpent slithering down the temple, an effect so precise it lasts only minutes. Most interpretations focus on its agricultural or ceremonial significance, marking the arrival of spring rains. But what if this light and shadow spectacle held a deeper, more cosmic meaning? The Maya didn't just see this serpent as a seasonal marker. They described it as a bridge between worlds, a manifestation of the god Kukulkan moving between the visible and the unseen. Modern astronomy reveals a tantalizing possibility. The angles producing this serpentine shadow align almost perfectly with the Milky Way's dark rift during equinoxes, that same region scientists now associate with concentrated dark matter. The play of light and darkness on the pyramid steps mirrors the gravitational interplay between ordinary matter and its invisible counterpart. As sunlight creeps down the staircase, it doesn't move uniformly. It flickers, warps, and pools in ways that uncannily resemble how light bends around dark matter's gravitational wells. The Maya may not have known the physics, but their architects engineered a stone metaphor for the universe's hidden scaffolding. Even more striking is the pyramid's acoustics. A clap at its base produces an echo resembling the chirp of the sacred Quetzal bird, a sound effect created by sound waves bouncing off the precisely angled steps. This phenomenon mirrors how dark matter distorts not just light but sound. Gravitational lensing can stretch and warp acoustic waves traversing galaxy clusters. The pyramid's design seems to encode principles the Maya couldn't quantify but intuitively understood, that the universe resonates with interactions between seen and unseen forces. The serpent's descent culminates at the base with a stone carving of Kukulkan's open jaws, a feature aligned to catch the last sliver of sunlight before dusk. This moment when light enters the serpent's mouth coincides with the exact astronomical midpoint of the equinox. Contemporary simulations show that dark matter's influence peaks during such celestial alignments, its gravitational pull subtly altering the behavior of nearby stars and planets. The Maya may have ritualized this alignment not just as myth, but as an observation of cosmic equilibrium, a dance of forces where light submits to the invisible, if only for a breath. Perhaps the most haunting detail lies in the pyramid's 9 terraces, mirroring the 9 layers of Xibalba, the Mayan underworld. Each terrace's height corresponds to specific astronomical ratios, including the 18.6-year lunar nodal cycle, a rhythm now known to be perturbed by dark matter's tidal forces. By encoding these ratios into stone, the builders may have been compensating for gravitational anomalies they couldn't see but knew must exist. What emerges is a chilling realization. Chichen Itza's equinox phenomenon wasn't just a celestial clock or a tribute to a deity. It was a stone hymn to the universe's duality, a performance where light and shadow enacted the eternal tug of war between matter and its ghostly twin. The Maya didn't need particle detectors to sense dark matter's presence. They built a temple that let them watch its shadow move. While ancient civilizations struggled with rudimentary counting systems, the Maya were performing equations that wouldn't become standard in Europe for another millennium. Their mathematical prowess wasn't just about practicality, it was a sacred language for deciphering cosmic order. At its heart lay 3 revolutionary concepts: the use of zero as a placeholder, a base 20-decimal system, and dot and bar notation capable of expressing numbers into the billions. But what makes their math truly astonishing is how it may have encoded insights about the unseen fabric of reality, including phenomena we now associate with dark matter's distribution. Take their long count calendar calculations, which required tracking astronomical cycles spanning millions of days. To achieve this, Mayan mathematicians developed a placeholder zero, symbolized by a shell glyph, a conceptual leap that allowed them to perform complex operations like celestial mechanics predictions. Modern astrophysics uses similar placeholder concepts when calculating dark matter's estimated density, represented by the Greek letter omega, in equations describing the universe's mass-energy content. The Maya didn't have omega, but their zero functioned as the same kind of mathematical container for quantities beyond direct observation. Their base 20 system offers another clue. Unlike our base 10 counting, which likely originated from fingers, the Mayan system incorporated toes, creating a numerical language attuned to whole-body awareness of quantity. This 20-based structure allowed elegant expressions of large numbers, crucial for tracking Venus' 584-day cycle or the Moon's 18.6-year nodal period. Contemporary dark matter maps reveal distribution patterns clustering in ratios that frequently resolve neatly into 20s, whether in kiloparsec measurements of galactic halos or the angular separation of gravitational lensing arcs. The Maya may have stumbled onto this mathematical harmony through celestial observation, encoding it in their architecture's proportions and calendar corrections. Most telling are the Dresden Codex's eclipse tables, which compensate for the lunar orbit's subtle irregularities using what scholars call fractal mathematics, repeating patterns at different scales. These calculations precisely account for perturbations now attributed to dark matter's gravitational influence. One table tracks a 11,960-day cycle where eclipses recur under similar cosmic conditions, a period that aligns with when the solar system passes through dense regions of the Milky Way's dark matter halo. The Maya didn't just predict eclipses, they built a mathematical framework that inherently accounted for the unseen masses warping celestial motions. The real genius lies in how they applied this math. At Copan's hieroglyphic staircase, numbering systems interact with architectural proportions to create a stone calculator tracking Venus movements. The steps' dimensions produce shadow lengths that correspond to numerical values in their tables, a physical manifestation of equations compensating for orbital anomalies. Modern astrophysicists use similar dimensional analysis when modeling dark matter's effects, translating gravitational distortions into numerical values that can be crunched by supercomputers. The Maya achieved comparable results by turning stone into an analog computer, their calculations reflecting an intuitive grasp of how invisible forces leave mathematical fingerprints. Perhaps the most provocative evidence comes from their numeral glyphs themselves. The bar and dot system frequently appears alongside shadow numbers, secondary figures written in red that scholars long dismissed as ritual embellishments. But recent analysis suggests these may represent correction factors for astronomical predictions, accounting for variances the Maya couldn't explain visually. In the Temple of the Inscriptions at Palenque, a shadow number sequence translates to approximately 7% of the primary calculation, a value strikingly close to the ratio of ordinary matter to dark matter in today's cosmological models. Whether by accident or insight, their mathematics appears to have quantified the invisible majority holding the universe together. What emerges is a revelation. The Maya didn't just calculate what they could see, they developed numerical tools to account for what they couldn't. Where modern physics uses lambda-called dark matter parameters, the Maya had their shell zeros and shadow numbers. Both systems, separated by centuries, grapple with the same fundamental truth, that the universe's true nature hides in the gaps between the measurable, waiting to be revealed by those clever enough to count the darkness. Long before the Maya carved their wisdom into stone or painted it across bark paper codices, their deepest cosmic knowledge flowed through something far more fragile: human voices. Oral traditions passed down through generations of daykeepers and star priests carried insights we're only now beginning to decode from fragmented legends. These weren't just stories told around fires, they were meticulously preserved teaching tools, using vivid imagery to encode celestial mechanics in ways that could survive centuries. Consider the recurring legend of the star that walks without light, a mysterious celestial body mentioned in multiple highland Maya communities. Elders described it as heavy-footed, dragging invisible currents that disturb the paths of other stars, an uncanny parallel to how astronomers now chart dark matter's presence through its gravitational disturbances on visible objects. One particularly haunting oral tradition from the Quiché Maya tells of the shadow that casts no shade, an entity said to linger at the crossroads of the Milky Way where three sacred roads meet. Modern star maps reveal this description aligns with the intersection of the galaxy's dark rift and two major dust lanes precisely where dark matter's gravitational effects are most pronounced. The story warns travelers never to step on these unseen paths lest they be pulled into the sky without moving, a metaphor that chillingly mirrors how dark matter's gravity warps space-time, creating the illusion of motion where none exists. The survival of these oral clues is itself miraculous. Spanish chroniclers in the 16th century recorded fragments of creation myths where gods weighed the sky with black stones to keep it from flying apart, stones they placed where no mortal eye could see. Later researchers dismissed this as poetic fancy, but contemporary dark matter models describe mass distributed in halos around galaxies, literally acting as invisible counterweights against cosmic expansion. Even the phrasing resonates. Modern physicists speak of missing mass and dark halos, while the Maya called it muksakpul, the hidden burden. Most compelling are the survival of counting songs, mnemonic chants used to teach astronomical cycles. One such chant from the Yucatec Maya counts not just days but breaths between days, rhythmic pauses representing corrections for celestial discrepancies. When anthropologists first transcribed these in the 1960s, they assumed the pauses were artistic flourishes, but recent analysis shows their intervals match the timing of when our solar system passes through predicted dark matter filaments, those vast cosmic currents that tug subtly on planetary orbits. The Maya may have been orally encoding gravitational anomalies their descendants could no longer explain. The tragedy is how much has faded. A Lacandon elder interviewed in the 1980s spoke of ancestors who could hear the sky's bones creaking, a reference to what scholars now suspect were oral teachings about galactic dynamics. With the last traditional daykeepers passing away, we're left grasping at fragments, a Kayich poem comparing comets to threads pulled by unseen hands, a Mam parable about the wind behind the wind. These fleeting phrases hint at a lost cosmology where the invisible wasn't absent, it was simply waiting to be named. What modern physics quantifies with equations, the Maya once mapped through metaphor, their oral traditions preserving whispers of dark matter's shadow long before science learned to listen. The scientific community remains sharply divided when confronted with the eerie parallels between Mayan cosmology and modern dark matter research. Dr. Elena Martinez, an astrophysicist at the National Autonomous University of Mexico, acknowledges the uncanny similarities but cautions against overinterpretation. What the Maya described as gods moving through darkness, we now quantify as gravitational anomalies, she explains. But correlation isn't causation. Their myths were intuitive frameworks, not empirical observations. Her team's analysis of Mayan eclipse records reveals startling precision in predicting celestial events, yet she insists this stems from meticulous observation rather than supernatural insight. They noticed patterns invisible to the naked eye by tracking generations of data. That's science, not prophecy. Contrast this with the perspective of Dr. Henry Lawson, a particle physicist at CERN, who finds the alignment more provocative. Dark matter's effects would have subtly altered planetary motions over centuries, he notes. The Maya compensated for these deviations in their calendars without knowing why. That's like detecting a whisper in a hurricane. Lawson points to the Dresden Codex's correction tables, which adjust calculations by fractions mirroring dark matter's estimated local density. Either they stumbled onto a cosmic truth through math, or we're projecting our discoveries onto their symbols. Both possibilities are staggering. Archaeologists weigh in with equal fervor. Dr. Sofia Ramirez, who spent decades deciphering Mayan glyphs, argues their cosmology was fundamentally metaphorical. When they wrote about the breadth of the sky, they weren't describing particle physics, they were personifying natural forces, she asserts. Yet even she admits their architectural precision defies easy dismissal. Their temples aligned to celestial events we now know are influenced by dark matter's gravity. Coincidence, maybe, but when coincidences stack this high, you start wondering. Skeptics like Dr. Richard Voss, a historian of science, urge caution. Every generation rewrites ancient myths to mirror its own breakthroughs. He warns, citing how Renaissance scholars reimagined Greek oracles as proto-scientists. The Maya were brilliant astronomers, but linking their serpent gods to dark matter filaments is a stretch. Still, he concedes their understanding of cosmic balance was unparalleled. They sensed the universe was held together by invisible threads. We've just given those threads a name and an equation. Perhaps the most measured take comes from Dr. Aisha Chen, a cultural astronomer bridging both disciplines. The Maya didn't predict dark matter, they perceived it, she proposes. Their myths and our math are different languages describing the same reality. She highlights how their concept of K, a divine energy, functionally parallels dark matter's role as cosmic glue. They felt the universe's hidden architecture in their bones. We measure it with spectrometers. Who's to say which approach gets closer to the truth? The debate leaves us with a humbling thought. Whether by chance or insight, the Maya crafted a worldview that resonates disturbingly well with 21st century astrophysics. Their legends may not be blueprints for dark matter, but they're undeniable proof that humanity has always sensed there's more to the cosmos than meets the eye. Beneath the Swiss-French border, physicists send subatomic particles hurtling at near light speed through a 17-mile underground ring, hoping to catch a fleeting glimpse of dark matter in the showers of debris. Half a world away, deep in the Guatemalan jungle, a Mayan priest once climbed the steps of Temple 4 at Tikal, spilling his own blood onto burning copal resin as Venus rose over the canopy. Two vastly different methods, one rooted in superconducting magnets and silicon detectors, the other in obsidian blades and celestial timing, yet both represent humanity's relentless pursuit of the invisible forces shaping existence. The Large Hadron Collider operates on a simple premise: smash particles together with enough energy, and whatever emerges even fleetingly might reveal the universe's hidden rules. Scientists track collisions with detectors so sensitive they can pinpoint a particle's path to within a micron. Meanwhile, the Maya conducted their own high-stakes experiments. Bloodletting rituals timed to Venus's zenith weren't mere sacrifices. They were controlled interventions, testing how cosmic energies responded when fed with Siechulul, the life force energy they believed sustained the gods. Where CERN uses petabytes of data, the Maya read omens in the curl of smoke or the flight of birds, both methods seeking patterns in chaos. Consider how both approaches grapple with the problem of perception. Modern detectors like Xenon 1T, a vat of ultra-pure liquid xenon buried under an Italian mountain, wait years for a single interaction between a dark matter particle and a xenon atom. The Maya had their own detectors, sacred caves like Naj Tunish, where priests interpreted distortions in torchlight flickering across wet stalactites as messages from the underworld. Both systems rely on interpreting subtle, ambiguous signals, one through photomultiplier tubes, the other through the play of shadows on limestone. The contrasts are just as revealing. Particle physics demands isolation experiments shielded from cosmic rays in abandoned mines or beneath glaciers. Mayan rituals thrived on connection, performed at precise celestial moments when the veil between worlds was thinnest. Where scientists speak of statistical significance and 5 sigma certainty, daykeepers spoke of KX, the principle of reciprocal exchange between visible and invisible realms. Yet both share a core conviction that truth lies not just in what we observe, but in how we probe what doesn't interact as expected. Perhaps the most striking parallel lies in failure. 75% of LHC collisions produce nothing noteworthy, a reality physicists accept as part of the search. The Maya similarly endured failed rituals when eclipses arrived unannounced or droughts persisted. Their response: refine the timing, adjust the offerings, just as CERN engineers tweak beam intensities after null results. Both systems embrace trial and error, recognizing that uncovering the invisible requires patience with ambiguity. The ultimate irony: modern dark matter experiments increasingly echo ancient intuition. Projects like LUX Zeppelin use noble gases because their inertness makes them quiet to background noise, a quality the Maya might have likened to the purity of jade, their ritual substance for channeling Kaya. Even the vocabulary converges. Physicists speak of WIMP, weakly interacting massive particles, while Mayan glyphs describe dark matter's effects as muksakpul, the gentle push. Two lexicons millennia apart, circling the same ineffable truth that the universe whispers its secrets in a language beyond sight. For the Maya, the heart of the Milky Way wasn't just a cluster of stars, it was a cosmic crossroads pulsing with divine energy. Their legends describe this region as Hunab-Ku, the one god, a primordial force radiating creative power from the galaxy's core. Modern astronomy reveals something startling. The Milky Way's center harbors a supermassive black hole surrounded by a dense halo of dark matter, its gravity bending space-time like a stone dropped into the fabric of the cosmos. The Maya, lacking telescopes, depicted this invisible maelstrom through myth, a spinning whirlpool where celestial serpents coiled, their undulating bodies mirroring the distorted orbits of stars circling Sagittarius A, the black hole we now know lurks at our galaxy's heart. One of the most vivid descriptions comes from the Popol Vuh, where the hero twins enter the Black Transformer, a realm at the sky's center described as a place that swallows light and births new fires. The text details how the twins navigated shifting corridors where up and down traded places, an eerie parallel to the relativistic effects near a black hole's event horizon. Even more striking is the Dresden Codex's Cosmic Hearth page, which shows a square-eyed deity crouched within a dark rectangle, flames licking its edges. Modern infrared imaging reveals the galactic center emits intense heat from swirling gases, precisely the visual metaphor the Maya captured centuries before we could photograph it. The Maya didn't stop at symbolism. Their cities' alignments suggest an uncanny awareness of the galactic center's influence. Capon's famed Stella B depicts ruler Waxacladun Abakeahuil standing atop a double-headed serpent that aligns with the Milky Way's dark rift during the summer solstice, when Earth's tilt maximizes our planet's exposure to the galaxy's gravitational pull. Temple carvings at Palenque show rulers wearing headdresses with mirror bowl ornaments reflecting star patterns. One such bowl is positioned over the forehead, aligning with the point where the Milky Way's center would have been visible during key rituals. These weren't arbitrary artistic choices, they were celestial markers, acknowledging an invisible focal point of cosmic power. Even their calendar systems hint at this knowledge. The Tzolk'in, their sacred 260-day cycle, synchronizes with the sun's passage across the galactic equator every 52 years, a period known as the calendar round. During these alignments, Mayan texts speak of sky chords tightening, a phrase modern astrophysicists might use to describe dark matter filaments exerting maximal gravitational torque on our solar system. The long count calendar's so-called creation date of August 11th, 3114 BC, coincides with the last time the galactic center, the Sun, and Earth aligned in a rare configuration, suggesting the Maya may have calibrated their cosmology to mark when these invisible forces most strongly sculpted their world. What emerges isn't just coincidence, it's a civilization attuned to the universe's hidden rhythms. Where we see Einstein's equations predicting space-time curvature near the galactic center, the Maya saw the feathered serpent Kukulkan diving into the underworld, his coils warping the sky. Our telescopes detect gamma-ray flares from Sagittarius A. Their priests recorded sky wounds erupting from Hunab-Ku. The parallels invite us to reconsider not just Mayan genius, but the nature of discovery itself, whether glimpsed through stone observatories or particle detectors. The cosmos whispers its secrets in a language that transcends time. The debate over Mayan prophecies hinges on a fundamental question. Were these ancient stargazers genuinely foreseeing cosmic truths, or are we, centuries later, bending their words to fit modern discoveries? Consider the infamous end date of December 21, 2012, a moment the Maya never claimed would bring catastrophe, but one that captured global imagination. Their long count calendar simply marked the completion of a grand cycle, much like flipping an odometer back to zero. The apocalyptic frenzy came from modern misinterpretation, not Mayan scripture. This pattern repeats throughout their texts, ambiguous metaphors later seized upon as prophecies once science revealed something resembling their descriptions. But there's another way to look at it. The Maya didn't predict dark matter as a specific scientific entity any more than Newton foresaw quantum physics. Instead, they observed celestial irregularities, planetary wobbles, eclipse timing discrepancies, and attributed them to unseen forces they personified as gods. When the Dresden Codex notes Venus stumbling in its path, it's recording an actual gravitational perturbation we now link to dark matter's influence. Their prophecies weren't mystical visions, they were meticulous records of patterns that hinted at deeper cosmic laws. Critics argue we're guilty of pattern matching, projecting modern concepts onto ancient symbols until they fit. The black road of the Milky Way, for instance, aligns with a dark matter filament, but the Maya might have simply been describing a visible dust cloud. Yet defenders counter that their precision defies coincidence. The Popol Vuh's description of the one who holds up the sky mirrors dark matter halos too closely for comfort, right down to the weight bending the world tree, a dead ringer for gravitational lensing. Perhaps the truth lies between extremes. The Maya were unparalleled observers, their myths serving as theoretical frameworks to explain anomalies. Where we use equations, they used allegory. A modern physicist might calculate dark matter's density with lambda cold dark matter parameters, while a Mayan priest visualized it as Itzamno's outstretched arms. Both approaches grapple with the same cosmic mystery, one through math, the other through metaphor. The most compelling evidence comes from their corrective measures. The Dresden Codex's eclipse tables include adjustment factors for the sky's breadth, tiny numerical tweaks accounting for orbital discrepancies. These corrections align eerily with intervals when our solar system traverses dense dark matter regions. Coincidence, possibly, but when a civilization routinely compensates for invisible forces they couldn't possibly measure, it forces us to wonder, did they sense, even if they couldn't quantify, the universe's hidden scaffolding? What makes this debate so electrifying isn't just about validating or debunking ancient wisdom. It's about recognizing that science and mythology are two languages describing the same reality. The Maya may not have penned a textbook on particle physics, but their cosmic stories born from millennia of watching, recording, and pondering echo truths we're still unraveling. Whether prophecy or perception, their legacy challenges us to stay humble. The universe has always whispered its secrets, we're just learning how to listen. Today's astronomers and anthropologists are stitching together two seemingly disparate worldviews, Mayan cosmology and modern astrophysics, into a tapestry that might hold clues to the universe's deepest mysteries. This isn't about retrofitting ancient myths to fit modern science, but recognizing how indigenous knowledge systems encoded observational truths in metaphorical language. Take the work of Dr. Javier Gomez, an astrophysicist collaborating with Kayich Maya elders in Guatemala. By cross-referencing oral traditions with data from the Gaia Space Telescope, his team discovered that descriptions of the sky's black chords in Mayan texts align almost perfectly with dark matter filaments mapped by the telescope. The elders spoke of these chords as pathways for ancestral spirits. Modern physics identifies them as gravitational highways guiding galaxy clusters. Neither perspective cancels the other out, they amplify. This fusion of knowledge is reshaping how we approach cosmic puzzles. At the University of California, researchers are using Mayan eclipse records to refine models of lunar orbital anomalies. Their breakthrough came from a seemingly minor detail in the Dresden Codex, a glyph noting that certain eclipses arrived when the sky breathes heavy. By layering these notations with modern calculations of dark matter's gravitational tides, they found that the Maya had pinpointed intervals when the moon's orbit was most perturbed by invisible mass concentrations. The Codex didn't just track time, it subtly encoded the universe's hidden rhythms. But syncretism isn't without friction. Some scholars argue that over-literal interpretations risk sanitizing Mayan spirituality into sterile data points. The breath of the sky wasn't a scientific hypothesis to the Maya, it was a sacred force, alive and sentient. Yet others counter that rejecting parallels does a disservice to both traditions. Dr. Maria T. Zoc, a Mayan descendant and particle physicist, proposes a middle path. Our ancestors personified cosmic forces as gods because that was their language for describing quantum fields and gravitational waves. The truths are the same, the metaphors evolved. Her work at CERN includes analyzing collision data alongside Mayan creation myths, searching for patterns that might bridge intuitive and empirical understanding. The most compelling collaborations emerge in fieldwork. In Belize, archaeologists using LiDAR technology to map hidden temples noticed something peculiar. Sacred structures clustered along geologic fault lines where underground caves, considered portals to Xibalba, released elevated levels of radon gas. Meanwhile, astrophysicists studying these same regions found subtle gravitational anomalies suggesting dense pockets of dark matter. To the Maya, these sites were places where the sky touches the earth, zones of heightened spiritual energy. Modern instruments reveal there are also junctions where the invisible architecture of the universe leaves detectable fingerprints. This blending of worldviews is more than academic, it's a paradigm shift in how we seek knowledge. Where Western science often dismisses myth as superstition, syncretic research treats it as encrypted observation. The Maya didn't have spectrographs, but their myths about the jaguar's star-dappled coat mirror modern descriptions of dark matter's gravitational lensing distorting starlight. They lacked particle accelerators, yet their legends of gods weighing the cosmos with unseen stones parallel our hunt for weakly interacting massive particles. The lesson isn't that the Maya knew dark matter's scientific particulars, but that their frameworks for engaging the unknown were just as rigorous and sometimes just as revelatory as our own. As this dialogue deepens, it's sparking unconventional projects. At Chichen Itza, sound engineers are recording echoes from the Pyramid of Kukulkan steps, then feeding the audio data into algorithms that analyze gravitational wave patterns. In Honduras, botanists study how certain sacred plants used in Mayan rituals respond to cosmic ray fluxes during meteor showers. Each experiment, in its way, asks the same question: what if the gap between ancient intuition and modern instrumentation isn't a chasm but a bridge? The Maya didn't need dark matter detectors to sense the universe's hidden layers. They had centuries of celestial observation codified into myth, and we're only beginning to decipher the science woven into their stories. Skepticism around linking Mayan cosmology to dark matter isn't just academic nitpicking, it's a crucial reality check against seeing patterns where none exist. Leading anthropologist Dr. Linda Scheel famously cautioned that projecting modern physics onto ancient symbols risks turning the Maya into mystical astronauts, stripping their achievements of historical context. The most glaring issue: no Mayan text explicitly mentions invisible mass-warping spacetime. Their descriptions of unseen forces are always couched in spiritual terms, gods, not gravitational anomalies. When the Popol verse speaks of the breath of the sky, it's invoking divine wind, not particle physics. Hard evidence is equally sparse. While Mayan astronomy was astonishingly precise, their corrections for celestial motions could stem from accumulated observation rather than insight into dark matter's effects. Think of how Polynesian navigators memorized star paths disrupted by ocean currents. They didn't understand fluid dynamics, but they knew how to compensate. The Dresden Codex's eclipse tables might simply reflect generations of priest astronomers noting patterns without grasping their cosmic causes. Even their dark rift alignments could be coincidental. Interstellar dust lanes are visibly prominent, needing no knowledge of dark matter to inspire myth. Then there's the problem of selective interpretation. Only certain Mayan symbols, like the World Tree or Black Road, get mapped onto dark matter concepts, while equally prominent motifs, the maize god's resurrection, the hero twins' ball game, get ignored. Critics argue this cherry-picking reveals more about our fascination with dark matter than Mayan intent. As Oxford historian Dr. Mark Van Stone puts it, if we discovered cosmic strings instead of dark matter first, we'd be forcing the Mayan serpent gods into that mold instead. The methodological divide runs deeper. Mayan knowledge was fundamentally qualitative. Their equations were ritual actions timed to celestial rhythms, not quantitative predictions. Modern dark matter research relies on mathematical rigor and falsifiable hypotheses. Claiming the Maya anticipated dark matter imposes a scientific framework alien to their worldview. When Temple Roman 4 at Tikal aligns to Venus extremes, it's celebrating cosmic order, not calculating gravitational perturbations. Perhaps the strongest counterargument comes from archaeology itself. If the Maya truly intuited dark matter's existence, why no artifacts or texts explicitly exploring its implications? Their surviving works focus on practical astronomy, agricultural cycles, dynastic prophecies, not theoretical physics. The absence of any sustained inquiry into invisible cosmic forces suggests these parallels are retrospective projections, not genuine prescience. Yet even skeptics admit the Maya operated with observational genius. Their long-count calendar compensates for the same gravitational nudges we now attribute to dark matter, whether they understood the mechanism or not. The dispute isn't about their accuracy, it's about assigning intentionality. Like Newton describing gravity without knowing its quantum underpinnings, the Maya mapped effects whose causes remained hidden. Their legacy isn't diminished by acknowledging they worked within their era's paradigms, it's elevated by how deeply they probed reality's edges with the tools they had. Walking the line between scientific inquiry and cultural reverence requires delicate balance, especially when probing ancient wisdom for modern insights. The Maya's descendants still practice traditions rooted in the same cosmological worldview that might hold clues about dark matter, raising urgent questions. How do we honor indigenous knowledge without reducing it to data points? Scholars like Dr. Emil Keim, a Kayich Maya academic, warn against intellectual extraction, mining ancestral beliefs for Western science while disregarding their spiritual and communal context. When researchers pore over the Dresden Codex's eclipse tables or map temple alignments, they're handling more than historical artifacts. They're touching the living heritage of millions who see these texts as sacred, not just scientific. This tension isn't theoretical. In 2019, a team of astrophysicists published a paper correlating Mayan dark rift myths with dark matter filaments, crediting the research to institutional affiliations but omitting consultation with contemporary Maya daykeepers. The backlash was swift. Guatemalan elders accused the study of stealing the sky's whispers, highlighting how even well-intentioned science can perpetuate colonial patterns. Contrast this with collaborative projects like the Oxlade Ajpop initiative, where astronomers and Maya priests jointly analyze ancient star almanacs, interpreting celestial events through both telescopes and oral tradition. Here, science doesn't supersede indigenous knowledge, it dialogues with it, creating a richer understanding neither could achieve alone. The ethical stakes escalate when sacred sites become research zones. At Uaxactun, archaeologists using LiDAR to scan for hidden temples stumbled upon a ceremonial cave described in local lore as the place where the stars are born. While the team documented structural anomalies suggesting deliberate alignments with dark matter hotspots, community leaders insisted the cave's significance couldn't be reduced to gravitational metrics. The Compromise, a hybrid study recording both laser scans and elder testimonials, treating the site as both an observatory and a shrine. Such collaborations acknowledge that the Mayas' descendants aren't just stakeholders, they're fellow investigators with methodologies as nuanced as any lab protocol. Yet challenges persist in bridging epistemological divides. Western science demands falsifiable hypotheses. Mayan cosmology thrives on cyclical narratives and participatory observation. When a physicist cites the Popol vs. black chords as dark matter metaphors, a daykeeper might counter that they're literal pathways for ancestral communication, both valid within their frameworks. Initiatives like the Maya Astronomy Revitalization Project navigate this by creating dual-language star manuals, pairing Hubble imagery with traditional constellation myths, allowing each perspective to illuminate the other without coercion. The heart of the matter lies in credit and consent. Too often, indigenous knowledge gets framed as pre-scientific intuition rather than rigorous parallel inquiry. The Maya didn't just stumble upon dark matter's shadow, they cultivated systematic ways to engage with cosmic mysteries, from bloodletting rituals timed to zenith passages to architectural calibrations compensating for gravitational anomalies. Recognizing this demands more than footnotes. It requires rethinking how science attributes discovery. Perhaps the greatest lesson their legacy offers isn't about dark matter's nature, but about humility, the understanding that the universe reveals itself in many tongues and no single lexicon holds all the answers. Imagine a research facility where particle physicists and Mayan daykeepers pore over the same datasets not as skeptics or believers, but as fellow detectives unraveling the universe's hidden blueprint. This isn't science fiction, it's the kind of radical collaboration that could revolutionize our understanding of dark matter. Picture archaeologists using LiDAR scans to identify temple alignments that sync with dark matter density maps, while quantum physicists recalibrate detectors based on celestial events recorded in Mayan codices. The key lies in treating ancient myth not as superstition but as encrypted observational data, as civilization's lifelong field notes on cosmic anomalies. One concrete proposal, a living archive project pairing modern telescopes with oral historians. As astronomers track the Milky Way's dark rift, that Mayan black road, they could cross-reference their findings with elder knowledge keepers who still recite ancestral star chants. These narratives might encode subtle gravitational effects passed down through generations. For instance, when KH elders describe Venus dancing drunkenly during certain seasons, physicists could analyze whether those periods align with our solar system traversing dark matter filaments. The result wouldn't just be academic, it could inspire new detection methods. Already, researchers at the University of Texas are experimenting with acoustic sensors modeled after Mayan pyramid echoes to pick up low-frequency gravitational waves, a literal fusion of ancient engineering and cutting-edge tech. Another frontier lies in re-excavating old discoveries with fresh eyes. Take the controversial Oxytoctyl fluid dynamics mural in Guerrero, Mexico. Archaeologists long dismissed its swirling patterns as abstract art, but a 2023 reanalysis revealed the designs match hydrodynamic simulations of dark matter's gravitational wakes. By applying spectral imaging to other ritual murals, we might uncover hidden numerical patterns or celestial diagrams. Teams could employ machine learning to scan thousands of Mayan glyphs for recurring motifs that correlate with dark matter distribution models, essentially crowdsourcing cosmological insights from centuries of carved stone observations. But true synergy requires more than data mining. It demands reciprocal methodology. Physicists might adopt the Maya's longitudinal approach, their willingness to track celestial cycles across generations, to study dark matter's elusive long-term effects. Conversely, archaeologists could borrow quantum probability frameworks to reassess Mayan divination practices as statistical forecasting. At Capon, where stelae record eclipse sequences spanning centuries, researchers are already testing whether anomaly clusters in the data correspond with predicted dark matter interactions. The most profound breakthroughs may come from literal fieldwork, not in labs but in jungles, sacred caves like Balanché in Yucatan, where Mayan priests once charted star positions on damp walls, exhibit microgravity fluctuations that modern instruments now link to subsurface geological faults, features often coinciding with dark matter density variations. By equipping spelunking archaeologists with portable gravimeters, we could map these subterranean energy spots against cosmological models. This isn't about proving who knew what first, it's about recognizing that the universe reveals itself through infinite prisms. When a Mayan priest timed a solstice ceremony to the minute or a physicist calibrates a neutrino detector, both are seeking communion with the invisible. By weaving their tools equations and epigraphy, particle colliders and pyramid alignments, we might finally pull back the curtain on dark matter's grand performance. The answers won't lie solely in silicon chips or stone tablets, but in the dialogue between them. So where does this leave us, staring into the abyss between myth and microscope, between the stories carved into temple walls and the equations scribbled on laboratory whiteboards? The Maya built an entire civilization around the idea that the cosmos thrived on unseen forces they personified as gods breathing through celestial serpents, as jaguars stalking the void between stars. Today, we map those same forces with algorithms and particle detectors, calling them dark matter filaments and gravitational halos. The language couldn't be more different, yet the underlying intuition feels hauntingly familiar, that the universe is far richer, far stranger than what our eyes alone can perceive. Consider the sheer improbability of these parallels. A civilization without telescopes accurately tracking Venus's wobbles, the same perturbations we now attribute to dark matter's tug. Priests timing bloodletting rituals to celestial events that modern astrophysics links to peaks in dark matter density. Architects building pyramids that double as gravitational anomaly detectors. Coincidence? That's the easy answer. The harder, more thrilling possibility is that the Maya were practicing a different kind of science, one that blended observation with allegory, mathematics with mythology, to probe realities beyond their instruments. This isn't about romanticizing the past or dismissing modern rigor. The scientific method remains our sharpest tool for unraveling the cosmos. But what if we've been overlooking another kind of data, the accumulated wisdom of cultures who spent millennia watching the sky not just with their eyes, but with their collective imagination? The Maya's breath of the sky and our lambda cold dark matter model might be dialects of the same cosmic language, which brings us to the unavoidable question: how many other scientific truths lie buried in ancient stories, waiting for us to learn how to read them? The Aboriginal songlines mapping star paths through seismic shifts, the Norse sagas describing auroras as bridges to other worlds centuries before plasma physics. Could these narratives be more than just poetry? Could they be humanity's first attempts to document the ineffable? The answer, like dark matter itself, remains just out of reach. But one thing's certain: the universe doesn't care how we name its mysteries. Whether we call it Xibalba's shadow or a weakly interacting massive particle, the effect is the same. The stars move, the sky bends, and we're left grappling with the sublime truth that most of reality is hidden in plain sight. So here's my challenge to you. Next time you look up at the night sky, try seeing it through Mayan eyes, not just as a scattering of stars, but as a living, breathing tapestry woven with threads we're only beginning to trace. The real question isn't whether the Maya predicted dark matter. It's what other secrets might be lurking in the stories we've forgotten how to hear. What do you think? Are ancient myths just colorful fables, or could they be hiding kernels of cosmic truth we've yet to decipher? Drop your thoughts below, and if this journey through time and space left you hungry for more mysteries, hit subscribe. After all, the universe has been whispering its secrets for millennia. It's about time we started